OpenAI has done it again, and the new O1 model, even in its preview version, is truly impressive. With remarkable advancements in mathematics and science, this video will evaluate its ability to solve an engineering-level mathematical problem, as well as assess the accuracy of its results. Hello, my name is Jesus Gonzalez, and I had the opportunity to read about the impressive achievements of the OpenAI O1 preview model, and honestly, it left me amazed. This model ranks in the 89th percentile in competitive programming questions code forces, which is already quite impressive. But that's not all. It's also among the top 500 students in the American Invitational Mathematics Examination, one of the tests used to select students who will advance to the USA Mathematical Olympiad and eventually become part of the US team for the International Mathematical Olympiad. Personally, I wanted to conduct my own review, so I made a comparison between the 4.0 model and the O1 preview model in the area of mathematics. However, I want to clarify that the objective is not to teach the mathematical method used for the evaluation, but rather to introduce a method complex enough to evaluate OpenAI's new model. The method I used for the tests is a numerical method called Newton-Raphson, which, in simple terms, is a quick way to find the root of an equation. That is, a value of x, where the function f of x is equal 0. Imagine you have a curve, and you want to know where it crosses the x-axis. The method starts with an estimate of that point, and then refines that estimate step by step using the slope of the curve at that location. It sounds complicated for an AI to solve, doesn't it? The reason for using this method is that it's typically taught at the undergraduate level, or at least I studied it during my engineering studies, and I believe it is sufficiently complex. This is because it uses differential calculus and involves performing various iterations, using the values from the previous iteration. Usually, 5 iterations are enough to give us a value with sufficient precision. The first 2 tests I conducted were with simple functions, as we can see in the history. It's important to note that the model on the left side is 4.0, while the model on the right is the O1 preview. The first test involved a quadratic function, and the results were quite similar in both cases. However, the O1 preview model, by default, provided a step-by-step explanation, and even generated a table detailing the iterations, which allows for a simplified view of the iterative process and the results. In contrast, with the 4.0 model, I had to modify the prompts to achieve a similar outcome, as shown in the history. Now, let's skip ahead to where the tests became a bit more complex. For this, I introduced a logarithmic function, and this is where inaccuracies began to appear in the 4.0 model. From the very first iteration, it produced an incorrect result, which occurred during my initial tests in a different chat. The error was due to an incorrect summation in the divisor, as well as fewer decimals being used in the summation of the dividend, leading to rounded and therefore less accurate values. Reviewing the results and using Excel to perform the summations, I noticed that the summation of f of x was incorrect, and therefore the result of the first iteration was incorrect. And obviously, the subsequent iterations yielded incorrect values as well. Regarding the O1 preview model, all the iteration results are correct, and they are also more precise due to the use of 10 decimals in the values. Additionally, the default explanation is more detailed at each step, unlike in 4.0, where I had to be very specific and detailed in the prompts to get a similar result. I even specified in the prompt to use 10 decimals, which might be why it corrected the calculations and improved the accuracy of the results. In conclusion, the new O1 model from OpenAI, even in its preview version, stands as a groundbreaking advancement in the field of artificial intelligence. Its ability to handle complex engineering-level mathematical problems with such precision and detail is nothing short of remarkable. The model not only delivers accurate results, but also provides an in-depth, step-by-step breakdown of its processes, setting a new standard for AI capabilities. As we move forward, the O1 model promises to revolutionize research and innovation across disciplines such as mathematics, physics, biology, and beyond, solidifying OpenAI's position at the forefront of advancements in artificial intelligence.